Okay, so we are going to look at the concept of work. And what is work? What do we mean when we do work? I mean, we're working all the time, we're doing our homework, we're working at work. What does that really mean? Well, in physics, work means something very specific. Let's imagine that we have a crate that we want to push along a surface. So with that crate, we're going to apply a force, and we're going to apply that force through a distance. That's what I do when I do work. Work is applying a force through a distance. How can I do more work? Well, I can increase my force. If I have a lot of force, that says increase my work. I can increase my force. If I apply more force, well, it kind of makes some intuitive sense that I could do more work. Increasing my force increases my work. And if I have to apply a force over a really long distance, well, that's going to take a lot of work. So increasing the distance that I apply that force also increases the work. So intuitively, what work depends on makes a lot of sense to us in terms of what we already know about things. And that leads us to the relationship of work, which is a force times a displacement. Now, the true relationship for work is a dot product, but for the purposes of this class, which is a conceptual-based course, we aren't going to worry about the dot product. But that dot product actually comes from something special about this work. It's not just any force, it's actually a special force. So let's look at how that might be. I want you to imagine that we're applying two different forces on this crate. One purely horizontal in the same direction as this displacement, and one with the exact same strength, same amount of force being applied, but being applied at an angle. Which one do we think is going to do more work? Which one's more effective at getting this crate to move that distance? We probably intuited that the force purely horizontal is going to be more effective. And it is. The amount of work we do is related to the parallel force, parallel to that displacement. So the more parallel my force is, the more effective it is at doing work. I get more work done. For the purposes of our conceptual-based course, we're always going to have forces acting along the same dimension as the displacement. And we can use this simplified version of our work relationship of force times a displacement. Now, work is a scalar quantity, which means it doesn't care about direction. But we do talk about positive and negative work, not in terms of right or left, but in terms of helping or hurting. If I do positive work, my force is in the same direction, as my displacement. If I want to move my crate from position 1 to position 2, and I apply a force to do that, in the rightward direction, I'm applying a force that's helping the crate move in that direction. I'm going to do positive work. But you can imagine that my snot-nosed little kid pushes against me just to make my life difficult. If he were to apply a force in this direction, we'll say the force of Toby, in that direction, well, that's opposite the displacement that the crate is doing. I'm still winning, but Toby's hurting me. He's working against me. So when the force is in the opposite direction, we have negative work. When the force is in the same direction as the displacement, our work is positive. When the force is opposite the displacement, our work is negative. So when we look at the overall work acting on an object from all the forces that are interacting with the object, then we can assign a direction, positive or negative, not right or left or up or down, but we can define a positive or negative work depending on whether it's helping, moving in the direction of the displacement, or hurting, moving opposite the displacement. Now the last piece of information we want to look at about work is what about other forces that are acting, that aren't acting parallel. So let's take our example one more time. And we know that there is both a force of gravity acting on this crate as well as the normal force acting on the crate. Well, do either of them do work on the object? They're not really facilitating that crate from moving from this position to this position. So they do no work. Forces that act perpendicular to the displacement do no work. All right, so that's our basic idea about work. Force times a displacement, specifically a force in the direction of that displacement. Anything that happens perpendicular does no work. All right, good job.